Experimental research designs. By the end of this topic, you should be able to
define what is research design,
distinguish the ways in which good research designs differ from weak research designs,
explain the differences between a true experimental design and a quasi-experimental design, and
discuss the ethics of experimental research.
According to Christensen, research design refers to the outline, plan or strategy specifying the procedure to be used in seeking an answer to the research question.
It specifies such things as how to collect and analyze the data. The design of an experiment will show how extraneous variables are controlled.
The design will determine the types of analysis that can be done to answer your research questions and the conclusions that can be drawn from your research.
The extent to which your design is good or bad will depend on whether you're able to get the answers to your research questions.
If your design is faulty, the results of the experiment will also be faulty.
How do you go about getting a good research design that will provide answers to the questions asked?
It is not easy and there is no fixed way of telling others how to do it.
The best that can be done is to examine different research designs and to point out their strengths and weaknesses, and leave it to you to make the decision.
You should have an in-depth understanding of your research problem, such as the treatment you want to administer, the extraneous variables or factors you want to control, and the strengths and weaknesses of the different alternative designs.
You should be clear about your research questions and what is it that you intend to establish.
You should avoid selecting a design and then trying to fit the research question to the design.
It should be the other way round.
Most important is to see if the design will enable you to answer the research question.
You should be clear what factors you wish to control so that you can arrive at a convincing conclusion.
Choose a design that will give you maximum control over variables or factors that explain the results obtained.
Symbols used in experimental research designs.
Research design can be thought of as the structure of research. For example, it is the glue that holds all of the elements in a research project together.
In experimental research, a few selected symbols are used to show the design of a study.
O equals observation or measurement, for instance mathematics score, score on an attitude scale, weight of subjects, etc.
O1, O2, O3 on equals more than one observation or measurement.
R equals random assignment. Subjects are randomly assigned to the various groups.
X equals treatment, which may be a teaching method, counseling techniques, reading strategy, frequency of questioning and so forth.
Weak designs.
The following are considered weak experimental research designs.
One-shot design.
This is a simple design where the researcher makes a single observation without any follow-up measure or comparison with another homogeneous group.
For example, you want to determine whether praising primary school children makes them perform better in arithmetic as in the figure.
You measure arithmetic achievement with a test. To test this idea, choose a class of Year 4 pupils and start praising the pupils.
You will find that their performance in mathematics is significantly improved. You concluded that praise increases the pupil's mathematics score.
This design is weak for the following reasons.
Selection bias.
History.
Selection bias.
It is possible that the pupils you selected as subjects were already good in mathematics.
History.
The school had organized a motivation course on mathematics for Year 4 pupils. So, it is possible that it might influence their performance.
One group pre-test and post-test design.
To ensure that there was no pre-existing characteristic among the school children, a pre-test may be administered as illustrated in the figure.
If the children performed better in mathematics after they have been praised compared to the pre-test, then you can attribute it to the practice of praising.
This design is weak for the following reasons.
A. Maturation.
B. Testing.
Maturation.
If the time frame between the pre-test and post-test is long, it is possible that the subjects may have matured because of developmental changes.
Testing.
Sometimes the period between the pre-test and the post-test is too short and there is a possibility that subjects can remember their pre-test session and give inaccurate responses.
Activity.
20 pupils who had poor scores in arithmetic were taught arithmetic using the same DOCS method. 3 weeks later, when they were tested, their arithmetic scores improved. Thus, the same DOCS method improves their arithmetic performance.
1. Which type of research design is this?
2. What are some problems with this design?
Non-equivalent post-test only design.
The main weakness of the previous two designs is the lack of a comparison group and the vague correlation between the practice of praising and increased mathematics score. In the non-equivalent post-test only design, an attempt is made to include a comparison group, for example, control group, that did not receive any praises in the figure.
The dashed lines separating the experimental group and the control group indicate that the children were not randomly assigned to the two groups.
Hence, the two groups are non-equivalent.
Matching can be used, but there is no assurance that the two groups can be equated.
The only way one can have assurance that the two groups are equated is to assign the children randomly.
Selection bias.
Since there was no random assignment, it cannot be established that the two groups are equivalent.
So, any differences in the post-test cannot be attributed to the practice of giving praise, but other factors should also be considered such as ability, IQ, interest and so forth.
The three designs described are weak research designs, because they do not allow for extraneous factors that might influence the outcome of the experiment to be controlled within the research construct.
For example, if the attitude towards mathematics and additional tuition classes in mathematics are not controlled, it may not be possible to conclude that praise treatment affects mathematics performance, dependent variable.
Also, poor research designs do not attempt to randomly assign subjects to the groups.
This introduces extraneous factor affecting the dependent measure. Random assignment controls for both known and unknown extraneous variables that might affect the results of the experiment.
Self-check.
Identify the major differences between the one-shot design, one-group pre-test, post-test design and non-equivalent post-test only design.
Why are these designs considered weak?
Activity.
A teacher assigns one class of pupils to be the experimental group and another class is the control group. Both groups are given assigned post-test. The pupils in the experimental group are taught by their peers, while pupils in the control group are taught by their teacher.
Which research design is the teacher using?
How will you challenge the findings of the experiment?
True experimental designs.
What is a true experimental design?
According to Christensen, to be a true experimental design, a research design must enable the researcher to maintain control over the situation in terms of assignment of subjects to groups, in terms of who gets the treatment condition, and in terms of the amount of treatment condition that subjects receive.
In this topic, we will discuss two major types of true designs.
After-only design, and
Before-after design.
What is the difference between the two designs?
the after-only design relies only on a post-test, while the before-after design, as the name suggests, relies on both a pre-test and a post-test. The after-only research design gets its name from the fact that the dependent variable is measured only once after the experimental treatment.
After-only research design.
In other words, the post-test is administered once to the experimental group and the control group is provided in the figure. It shows an experiment in which the researcher is attempting to show the effectiveness of the inductive method in improving the science problem skills of 17-year-old secondary school students.
The sample was drawn from a population and randomly assigned to the experimental and control group.
Those from the experimental group were taught science using the inductive approach, while students in the control group were not taught using the inductive approach.
Instead, students in this group were taught the same science content using the traditional didactic approach, chalk and talk method.
In the above example, the experimental and control groups consist of two different sets of students.
This procedure is called a between subjects design, also sometimes known as an independent or unrelated design.
One advantage of this design is that the students are less likely to get bored with the study because each set of students is exposed to only one condition.
In a similar vein, the research is less susceptible to practice and order effects. However, you will need more students to participate in your research.
There is also a need to ensure that both groups of students are homogeneous in any confounding variables that might affect the outcome of the study.
This is because different students bring different characteristics to the experimental setting.
Even though we randomly assign students to experimental and control conditions, we might allocate students with one characteristic to one condition by chance, and this might produce confusing results.
Another research procedure in the after-only design is the within subjects design, sometimes known as repeated measures or related design.
In this design, the same students are exposed to two or more different conditions under comparison.
For example, you wish to study the effects of content familiarity on reading comprehension performance.
You can assign the same students to read two types of passages, one familiar and the other unfamiliar, and then analyze their comprehension performance.
One obvious advantage is that you need fewer students to participate in your research.
Besides, you will have much greater control over confounding variables between conditions because the same students are used in both conditions.
By large, the same individual will bring the same characteristics to the conditions. However, it is not all rosy in the within subjects design.
First, since the same students are exposed to different conditions, they might get bored by the time they are given the experimental treatment in the later condition.
Besides, there is an increased likelihood of practice and order effects.
One way to eliminate these effects is to introduce counterbalancing into your design.
In counterbalancing, you get half of your students to complete the first condition, followed by the second condition.
You then get the remaining half of your students to do the two conditions in the opposite order. The second condition is given first, followed by the first condition.
Before-after research design.
The before-after research design is perhaps the best example of a true experimental design that incorporates both an experimental and control group to which the subjects are randomly assigned as shown in Figure 7.6.
This research design is a good experimental design because it does a good job of controlling the extraneous factors such as history, maturation, instrumentation, selection bias and regression to the mean.
How is this done?
Any history events, for instance certain events subjects may have been exposed to, that may have produced a different result in the experimental group, would also have shown a contrasting outcome in the control group.
Here, it is assumed that the subjects in both groups have experienced the same set of events.
We can conclude that a true experimental research has three distinct characteristics, sometimes referred to as three basic principles of experimentation.
First, it involves intervention or treatment of independent variables. The independent variables are manipulated systematically to examine the effectiveness of the treatment.
Second, there is a control of variables. The purpose of this control is to rule out extraneous variables that might confound the experiment.
Third, a true experiment requires an appropriate comparison. For instance, comparison is made between two or more groups that are treated differently.
Self-check.
1. What is the main strength of true experiments?
2. What is the major difference between the two types of true experiments?
After only research design and before after research design.
Self-check.
1. What is the main advantage of using factorial design?
2. Why is the factorial design considered a true experiment?
3. Identify the differences between main effect and interaction effect.